In this video, we will be solving mathematics paper 1. So it's May-June 2016 and it's the second variant of the paper 1. So let's start with question number 1. So it's evaluate 2.05 plus 1.4, it's in the braces, and then multiplied by 0.2. So first of all, you will add these two numbers since they are inside the brackets, and then you will multiply the result with 0.2. So this will be equivalent to, so 2.05 plus 1.4, we can add them here. So 1.40. We'll add them, we get 5, 4, and 3, 3.45. So 3.45 multiplied by 0.2. So now you can do the decimal multiplication if you want. What I like to do is convert them into a fraction, then multiply, and then you can convert it back into the decimal. So 3.45 is equals to 345 over 100, and then you multiply it by 2 by 10. So now it's a little bit easier to multiply 345 by 2. You can also do it the other way where you multiply 3.45 by 0.2, and then you can add the decimal once you get the multiplication result. So here it's 5 2s are 10, 1 carry, 4 2s are 8, 1 9, 3 2s are 6. So it's equivalent to 690 divided by 1000, which is equivalent to 0.690. Since you have 3 zeros in the denominator, you will move the decimal point 1, 2, and then 3 times. So you will end up with the decimal right here. So this will be equal to 0.690, which is basically the same as 0.69. We can drop the 0 at the end. So this is equals to 0.69. So this is your final answer. Second part is evaluate 1 whole 1 over 3 minus 4 over 5. So you convert this into the improper fraction. So 3 ones are 3 plus 1, you get 4 by 3, and then you subtract 4 by 5. So you have 5 and 3 as the two denominators. You can calculate their LCM. Since they do not have any common factor, you'll divide by 3, and then you will have 5 as it is, and then you will divide by 5 to get ones, and then your LCM is basically 15. So you get 15 as your LCM. Since you multiplied the denominator 3 with 5 to get 15, you will multiply the numerator 4 by 5 as well. So you get 4 times 5 is 20, and then you subtract, so you multiplied the denominator 5 with 3 to get 15, so you'll multiply the numerator with 3 as well. So 4 times 3 is 12. You subtract, you'll get 8 over 15. So this will be your final answer, 8 over 15. So let's move on to question number 2, which states complete this description. A rectangle has rotational symmetry of order dash and dash lines of symmetry. So the order of symmetry is basically the number of times the object will look exactly the same while it's rotated through a full circle, which means it's rotated through full 360 degrees. So I've drawn this rectangle here to illustrate this question in a better way. So let's take this example where we have this rectangle and its original orientation is something like this. Now, if we start to rotate, let's suppose we rotate it 90 degrees, it looks like this. Another 90 degree, it looks like this, which is exactly the same as the original rectangle we have here. So this is one. Then we keep rotating 90 degrees, another 90 degrees, we are at 270. So here we are at 90 degrees, 180 degrees, 270 degrees, and then another 90, which is 360 degrees, and this one also looks exactly the same as this one, so this will be number 2. So when you rotate a rectangle a full 360 degrees, it looks exactly same as the original one 2 times. So the order of rotational symmetry for a rectangle will be 2 in this case. And then we also have to find the number of lines of symmetry a rectangle has. So a rectangle has 2 lines of symmetry, where the first one is this. So basically, if you look at a line of symmetry, the object is mirrored across the line of symmetry. So if you look at this side, the top one and the bottom one, they are mirror image of one another. So this is the first line of symmetry, and the second line of symmetry is through here. It's not in the center, but somewhere here in the center. And if you look at this line here, the rectangle is also mirrored across this line of symmetry on the left and on the right side. So these are the 2 lines of symmetry that a rectangle has. Part B is shade 4 more small squares in the shape below to make a pattern with a rotational symmetry of order 4. So first we need to find after how many degrees this pattern will repeat. That means you divide the full 360 degrees by your rotational symmetry order, which is 4 here. So 360 divided by 4 is 90 degrees. So that means this pattern will repeat every 90 degrees. So let me show you what I mean here. So I have this exact same shape as in the question. So since the pattern repeats after every 90 degrees, so I will rotate my shape 90 degrees. You can rotate your question paper to rotate the diagram as I'm rotating here. So this is the shape. So it looks like this after a rotation of 90 degrees. So now you have to make sure that all the boxes shaded in this diagram after the rotation are also shaded in the original diagram and not the other way around. So you're going from this shape, making sure everything shaded here is also shaded in the original diagram. So if you look at this shape, you have 4 corners that are shaded, and we in the original one we also have 4 corners that are already shaded. Then you have these 2 boxes, which are second row from the bottom, and the left 2 boxes. So if you look at here, these 2 are not shaded, so we need to shade these. So these are the 2 that will be shaded. And then if you go back to this shape, these 2 are shaded. So the second row from the top and the right 2. So if you come here, second row from the top and the right 2 boxes are these 2, and these are not shaded as well. So you will shade these as well. So now every box that is shaded in this diagram after the 90-degree rotation is also shaded here. So this is how you will solve. So let me write it down here. Make sure pattern of the boxes. So pattern after rotation is present in the original diagram. So you made sure that the pattern in the figure after the 90-degree rotation is present in the original diagram by making sure all the boxes shaded here are also shaded in this original. So let me bring it back to 0 degrees and shade the boxes here as well. So we're shaded these 2 and these 2, right? So let's shade these 2 as well. Let me actually choose the same color. So this is shaded, this one is shaded, and this one is shaded, and this one. So by definition, this shape will have a rotational symmetry of order 4. You can confirm it as well. So this is your original shape as this one. So every 90 degree, it will look exactly the same. So after 90 degrees, you can see that these boxes are shaded. So these boxes are shaded, these boxes are shaded, and these boxes are shaded as well. So pattern is repeating after every 90. So if I rotate it another 90 degree, bring it to 180 degrees, you will again get the same exact shape as the original one. You can double check the pattern again, and then it will happen again at 270 degrees. So 180 to 270 is another 90-degree rotation, and then again you have the same pattern as the original diagram, and then if you rotate it 360 degrees, you're back to your original orientation. So during a 360-degree rotation, there were 4 occasions when the pattern looked exactly the same as in the original diagram, after of course you have shaded these. So since the pattern repeated 4 times, or the shape looked exactly the same 4 times during a full 360-degree rotation. So the rotational symmetry is, the rotational symmetry order is 4. So basically to solve these, you first calculate the angle after which the pattern will repeat, then rotate the diagram and make sure whatever boxes are shaded in the diagram after 90-degree rotation are also shaded in the original one. So that will give you this rotational symmetry order 4. So question number 3 is, it is given that $100 is equivalent to 56 pounds. Use this information to draw a conversion graph between pounds and dollars on the grid below. So we have pounds on the y-axis and dollars on the x-axis. So we have $100 here, and this should be equivalent to 56 pounds. So we have 50 pounds right here in the middle of 40 and 60, and each small square represents 2 pounds. So we have 50 here, this would be 52, 54, and then 56 would be right about here. Yeah. So if we extend this and make it intercept the $100 line, we will get our first point on the conversion graph. Yep. So this would be your point, which is 100 on the x-axis and 56 on the y-axis. And then you can also say that $0 would be equivalent to 0 pounds, obviously. So you'll get your second point for the conversion graph at the origin. And then what you do is you basically draw a straight line between these 2 points. Let me quickly draw this here. Yep. So this is your conversion graph. Part B is, use your graph to convert $64 to pounds. So $64 on the x-axis. So on the x-axis, each small box represents $4 because there are 5 boxes and between 60 and 80. So 64 would be the first small line here. So this would be 64. So if you keep going up on this line here, right about here. So this would be your y value here. So since this is 2 boxes below 40 and each small box represents 2 on the y-axis, this would give you 36 pounds. 36 would be your answer. Let's move on to the next question. This is question number 4. So we have to complete the table given here, where one column is the fraction, one is decimal, the other one is, third one is the percentage. So 3 by 20, you have to represent it in the decimal form. So you divide 3 by 20. Since 3 is now less than 20, we add a decimal here and here as well. So if you divide 30 by 20, 20 times 1 is 20. You get a remainder of 10. You add another 0, bring it down, 100, and 20 times 5 is 100, and you get a 0 in the remainder. So this as a decimal would be 0.15. Then you have to convert it into a percentage, which is basically multiplying it by 100. So 0.15 multiplied by 100 would be very simple. You move the decimal 2 places to the right since you have 2 zeros in 100, so you get 15% here. Now you have percentage given that you have to find the decimal and the fraction. So we can convert it quickly to a decimal, which is 62.5%. So it would be 62.5 over 100 when you remove the percentage sign. So 100 has 2 zeros again, then you move 2 places to the left. So you get 0.625 as your decimal value. And then you have to represent this as a fraction. So that means 625 divided by 1000. So I converted this decimal into this fraction. So now we have to convert it into its simplest form. So you divide it by 5. You get 5 ones are 5 to 12, 5 to the 10 to 25. And here you get 200. Then you divide by 5 again. You get 25. Here you get 40. You divide by 5 again. You 5, get 5 and 8. So you have 5 over 8 as the fraction form. So question number 5, the table shows some information about temperatures in a city. On February 1st, the maximum temperature was -10, the minimum temperature was T. On March 1st, it was maximum temperature was 4, minimum temperature was -5. Part A is find the difference between the maximum and minimum temperatures on 1st March. So your difference would be maximum minus the minimum. So your maximum value on March 1st is 4 degrees. So you get 4, and then your minimum temperature is -5. So you do another minus and 5. So this minus into minus becomes plus 4 plus 5, and this equals 9. So your difference is 9 degrees Celsius. Part B is the minimum temperature T degrees Celsius on 1st February was 13 degrees lower than the minimum temperature on 1st March. Find T. So T is 13 degrees lower than the minimum temperature on March 1st. So T is minimum on 1st March minus 13, since it's 13 degrees lower than this. So your minimum on 1st March is -5, and then T is another 13 degrees lower. So you get -5 minus 13, and that is equivalent to -18. So the value of T is -18. Let's move on to question number 6. Express 96 as a product of its prime factors. So you do the factorization of 96. So since 6 is an even number, you divide it by 2. 2 4s are 8, 1 16, 2 8s are 16. Again divisible by 2, 2 2s are 4, 2 4s are 8. Again divisible by 2, you get 12. 2 again, you get 6. 2 again, you get 3, and now 3, and then you get 1. So you have 1, 2, 3, 4, 5 2's and 1 3. So 2 to the power 5 multiplied by 3 is your answer. 96 as a product of its prime factors can be written as 2 to the power 5 multiplied by 3. Part B is 24 is a common factor of 96 and the integer n. Given that n is less than 96, find the largest possible value of n. So we're given that 24 is a common factor of 96 and the integer n. That means n is a multiple of 24. So if we write the multiples of 24, we get 24. 24 times 2 is 48. 24 times 3 is 72. And 24 times 4 is 96. So since 24 is a common factor of both 96 and n, we know that n is one of these numbers which are multiples of 24. We can continue to write even further, but we are given that n is less than 96. So that means n is one of these three numbers where all these three are multiples of 24 and all these threes are less than 96 as well. So we have to find the largest possible value of n. So the largest possible value here would be 72. So n equals to 72 here. Let's move on to question number 7 here. So the table shows information about some flights from Dubai to Mumbai. We have departure times that are according to Dubai local time, and then you have arrival times that are according to Mumbai local time, and then you also have the flight duration. First part is work out the time difference between Dubai and Mumbai. So for this example, for the first one here, we know the departure time, we also know the arrival time, and you also know the flight duration. So here we have the arrival time according to Mumbai's local time. We can also compute the arrival time according to Dubai's local time by simply adding the flight duration to the departure time. So if you have departure at 3:30, and then you have flight duration which is 3 hours and 10 minutes. So you get 3:10 here. And then you have arrival. If you add both of these, you get 0, 3 plus 1, 4, and then 6:40. So this is arrival 6:40 according to Dubai's local time. And then you have arrival according to Mumbai's local time, which is 8:10. So if we subtract these 6:40 from 8:10, you basically get the time difference since these are both arrival times for the same flight. So your difference would be Mumbai is 8:10, and then you subtract 6:40 to get the time difference between the two cities. So you have to do carry over 1, so you get 7 here, and then you get 70 here. 70 minus 40, you get 30, and then 7 minus 6 is 1. So your time difference is basically 1.5 hours. Or you can also write it as 1 hour, 30 minutes. Part B is work out the local time in Mumbai when the 16:10 flight arrives. So this flight departs Dubai at 16:10. Then you also have the flight duration. So let's first compute the arrival time according to the Dubai's local time, which will be simply adding 2 hours 55 minutes to this departure time. And then we add another 1 hour 30 minutes to get the arrival time according to Mumbai's local time. So you have departure at 16:10 here, and then flight duration is 2 hours and 55 minutes. You add them and then you get the arrival. So these all are according to Dubai local time, both the departure and arrival. So if you add here, you get 5, 6, 1865. Since this is greater than 60, you add 1 here and subtract 60 here, you get 1905. So the arrival according to Dubai's time is 1905, and then according to Mumbai time it would be, if you add 1 hour and 30 minutes to it, your arrival time would be converted into Mumbai's local time. So 5 plus 0, 5, 3, and then 20. So this is your arrival time in Mumbai's local time. So this is your final answer, 2035. Let's move on to question number 8. So y is directly proportional to the square of x, which means y is directly proportional to x squared. So which means y is equals to some constant k times x squared. When when x is equals to 10, y equals to 20, find the value of y when x equals to 6. So first we need to find the value of k. We're given that when y equals to is 20, when k is, the x value is 10. So you get k into 10 squared, which means k equals to 20 over 100, which is basically 1 over 5. Now to compute y, when x is 6, we get y equals to kx squared, then replace the values, 1 by 5, k is 1 by 5, and then x is given as 6 squared, so you get 36 by 5, which is 7 whole 1 by 5. So you can give your value here, 7 whole 1 by 5. Move on to question number 9. So 50 students are asked what type of movies they like to watch. Of these students, 26 like comedy, 15 like both action and comedy, and 8 like neither action nor comedy. So using a Venn diagram or otherwise, find the number of students who like action but not comedy. So you have two categories here, comedy and action. So let me draw the Venn diagram here. So this represents the universal set here. And then let me draw green for comedy here. And then let's say red for action. And then we have some overlap here as well. So we have 15 that like both action and comedy. So you get 15 here. Let me quickly mark here. Let's say C for comedy and A for action. So you have 15 that like both comedy and action, and then you have a total of 26 that like comedy. So students who only like comedy would be 26 minus 15, which is 11. So you have 11 students that like comedy only and 15 that like both comedy and action, and a total of 26 who like comedy. And then we have 8 students that like neither action nor comedy. So these would be outside in the universal set. So using the Venn diagram or otherwise find the number of students who like action but not comedy. So we have to find the number of students who will be in this area who only like action movies but not comedy movies. So let's call this X. And that basically covers your whole universal set as well. So you have 50 students in total. So you have 11 here that only like comedy, 15 here which like both comedy and action. You have X here who like only action, and 8 students who do not like either of the action or the comedy. So the sum of these students is 50 since the survey was conducted across 50 students. So you have X plus 15 plus 11 plus 8 should be equal to 50. So if you add them here, you get 15 plus 11 is 26. 26 plus 8 is 34. And then you get the value of x as 16. So Your answer is 16. So 16 students here only like action movies and not comedy. Let's move on to question number 10. So solve these simultaneous equations. You have 6x plus y equals to 1 and 4x minus y equals to 4. So looking at these equations, you can see the sign for y is different. So we can use the elimination method. And so let's say if this is equation 1, oops, let me just erase this. So if this is equation 1 and this is equation 2, so if you add 1 and 2, you get 6x plus 4x, which is 10x, and then y cancels out, plus y minus y equals to 0, and then 4 plus 1 on the other side is 5. So you get x equals to 5 over 10, which is equals to 1 by 2. Then you can use the first equation using 1. We can find the value of y. So if we substitute x, so let's say 6x plus y equals 1. This is the first equation. Now substitute the value of x, 6 into 1 over 2 plus y equals 1. So this would be 2 1s are 2, 2 3s are 6. So y would be equals to 1 minus 3, which is equals to negative 2. So y equals to negative 2 and x equals to 1 over 2 here. Question number 11 is simplify these fractions here. So we see that we have x and y in the numerator and x and y in the denominator. So you can use the law of indices to basically write it as 5 by 15, and then you can use x power 7, and then since you're bringing this up into the numerator, you will subtract the powers of x, and then similarly you will do for the same for the y as well. So since y's power is greater than in the denominator, we can bring the one in the numerator down to the denominator to get y to the power 4 minus 1. So this, you can ignore this. So you get 5 to the power x to the power 7 minus 3 is 4. So 5x power 4. And then in the denominator, you get 15 and then y power y cube here. But we can also simplify the numbers here. 5 1s are 5 and 5 3s are 15. So we can write it as x power 4 and 3y cube. So this would be your answer, as we cannot simplify it any further. Part B is 4t squared over v to the power 4, and then this is a negative 1 by 2. So if we want to convert this into a positive 1 by 2, we take the reciprocal inside. So if you take the reciprocal, it becomes v power 4, 4t squared, and then whole to the power 1 by 2. Now you can bring the power in to the numerator as well as the denominator. So this would be equal to v to the power 4 into 1 by 2, and then 4 to the power 1 by 2, as well as t to the power 2 into 1 by 2. So you'll get v squared if you multiply these two. And then we know 1 by 2 is basically the square root. So the square root of 4 is 2. And then 2 multiplied by 1 by 2 is 1. So you just get 1 in the power. So v squared over 2t would be your final answer. All right, let's move on to question number 12. So the diagram below shows triangle ABC. On the diagram, construct the locus of points inside the triangle that are 3.5 centimeter from A. So if you want to draw a locus of points that are a certain distance from a point, you basically draw an arc with the given distance as the radius. So what we will do here is draw an arc that is inside the triangle, and that is 3.5 centimeter from A. So let me quickly bring up my geometric tools here. All right, so I have my compass and the ruler here. So we have to draw an arc of radius 3.5 centimeters. So let me just place my compass at 0 here, and then open it up to 3.5 centimeter. Yep, that's about 3.5. Okay, so we'll place the compass on point A, and we will draw the arc inside this triangle like this. So now all the points on this arc are 3.5 centimeter, since we opened our compass to 3.5 centimeter, and they are inside the triangle as well, as stated in the question. So the next part is we need to construct the locus of points that are equidistant from AC and BC, and also again inside the triangle. So equidistant from two lines AC and BC. So AC here and BC here. So that means we have to draw the angle bisector of angle BCA. So the angle bisector will give us a line somewhere down the middle here, and all the points on that line will be equidistant from the line BC and AC. So to draw the angle bisector, I'll place my compass here on point C, and then I can open it up to any length that I like. Just make sure it's not too small or just too big that you go outside the triangle. So this should be good. And then I can, so to draw the angle bisector, first you draw an arc that connects the two lines that make up the angle, which are BC and AC in this case. And then you place your compass on the points where the arc intersect the two lines. So the first point would be this one, and then you create a small arc like this, and then you place your compass on the other point where this arc intersects the other line, and then you can create another arc like this. So this gives you a point that is central, that will be on the angle bisector of angle BCA. So now what you have to do is simply connect the angle that's at C, the point here at C, and then this point with a straight line. So what I'll do here is create a straight line. Oops. So that line goes through the point C and the point that we have marked here. So since we need the locus of all the points in the triangle, so we go until we reach the boundary of the triangle, like this. So now the angle here above the angle bisector and the below angle here between the line AC and the angle bisector would be equal. So we have split the angle BCA into two equal halves, and all the points on this line will be equidistant from AC and BC. So part B is on the diagram, shade the region inside the triangle containing the points that are more than 3.5 centimeter from A. So all the points that are more than 3.5 centimeter away from A would be points that are outside this arc, since everything inside is closer than 3.5 centimeter from A. So the first condition is the region, all the points in the region are more than 3.5 centimeter from A and inside the triangle. So this becomes this whole region outside the arc, but still within the boundaries of the triangle. The second condition is uh, the points are closer to AC than to BC. So that means all the points that are towards the right side of this angle bisector of BCA, all these points in this region would be closer to the line AC compared to line BC. So the region that satisfies these two conditions, that they are more than 3.5 centimeter away from A and closer to AC than BC, would be this region here. So everything in this region, any point that you take inside this region would be more than 3.5 centimeter from A and closer to AC compared to BC. So question number 13 is write these values in order of size starting with the smallest. So you have to order them from smallest to largest. So we can actually compute the values represented by each of these. So 2 to the power of 5 means 2 times 2, 5 times like this. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. And then we know, let me write here, 5 squared is 25. Cube root of 1000 is, since there are three zeros here, so 10. Because if you take the cube of 10, that means you add another two zeros, which becomes 1000. So cube root of 1000 is 10 here, and then anything to the power 0, 27 to the power 0 is 1. So the smallest value here is 1. So that represents 27 to the power 0, which is would be your smallest. And then your next biggest value is 10, which is cube root of 1000. Then next value is 25, which is 5 squared. And then the last value remaining is 32, which is 2 to the power 5. Part B is write down one possible value of x that satisfies each inequality. So to represent this inequality in terms of x, we can take the square on both sides so that we can remove the square root. So 2 squared is less than x under root squared, which is less than 3 squared. So 2 squared is 4, less than this square and square root cancel out each other. So you get x, and less than 9. So x is less than 9 but greater than 4. So any number between 9 and 4, we can write here, let's say 6. So similar to what we did in the first part here, we can take the cube root on both sides so that we can represent this inequality in terms of x. So take the cube root on the right side, oh sorry, the left side, then x cube, cube root, and then cube root of 0. So negative 1 cube root is negative 1, because if you multiply negative 1 three times, you get negative 1 back. Minus 1 into minus 1 is 1, but if you multiply it again by minus 1, you get negative 1. And then cube root of x cube, which means we get x, cube root and cube cancel out, and then cube root of 0 is 0. So any value between minus 1 and 0 is a possible value of x. So notice that it doesn't say that x has to be an integer. So since x is not necessarily an integer, we can write a decimal value here, which is, let's say, negative 0.5, which is between minus 1 and 0. Moving on to question 14. The coordinates of the midpoint of the line AB are 1, 2. The length of the line AB is 10 units. If the gradient of AB is 0, find the coordinates of A and B. So gradient 0 means if you have y-axis and x-axis like this, and x-axis like this, gradient 0 means that the line AB is parallel to x-axis. So the line AB is something like this, parallel to x-axis. So the midpoint of the line are 1, 2. So let's say this is the midpoint here. So the x value is 1. So this point here is 1, 2. And the length of AB is 10 units. So if this is the midpoint, that means the length of the line here till the end is 5, and also the length to the left should be 5. Only then this becomes the midpoint of line A, B. So since this line is parallel to x, we know that the y coordinate of both A and B won't change. So A would be something comma 2, and B would also be some x value comma 2. To find the x value, we move 5 points to the left. So this value here would be 1, which is the point here. And then we move 5 to the left, which means 1 minus 5, which is equals to negative 4. So this x value here is negative 4. So this is your point A. And then similarly, to find the value of B, we add 5 since we move 5 points to the right to the x value here. So you get 1 plus 5 equals 6. So 6 would be the x value, x coordinate for the point B. So A is negative 4 and 2, and B is 6 and 2. Part B is if the gradient of AB is 3 over 4, find the coordinates of A and B. So let me again just sketch this line here. Now your line is something like this with a gradient of 3 by 4, and the midpoint is again 1, 2. So let's assume this is the midpoint here. So the x value is 1 and the y value is 2. And then A point A is here and B is here. And again, this distance is 5, and also this distance here is also 5, since 1, 2 is the midpoint of this line AB. So now we have to compute the coordinates of B and A. So given that the gradient is 3 by 4, we know that gradient of a line is rise over run. So that is basically change in value of y, which is delta y over delta x. So gradient 3 by 4 means that if I move 4 points to the right, which is run delta x, and so this is 4 points to the right, and then 3 points above, I should come back to this line since the gradient is 3 by 4. So let's assume there's some point here, and if I check the value of difference in value of y over difference in value of x, I should get the gradient, which is 3 by 4. So if I move, so yeah, so this gives you actually a right angle triangle here. And if you look at this triangle, your hypotenuse is 5, your base is 4, and your perpendicular length is 3. And if you use the Pythagoras theorem, 3 square plus 4 square is indeed equal to 5 square, because 9 plus 16 is 25. So that means actually that this point is indeed B. If you moved 4 points to the right and 3 points in the y direction, positive y direction, you'll actually land on B, because this distance is, as we know, since this is the midpoint, this distance is 5. So your value of B would be, you add 4 to the x value. So if your midpoint is 1, 2, you will, so mid is 1, 2, then A is, you add 4 on the x coordinate and 3 to the y coordinate, because we moved 4 points in the x direction and 3 points in the y direction. So you get 5 and 5 as your coordinate of A. And similarly, oh, sorry, this is B actually. Similarly, to find the value of A, you come down 3 points like this, and then you move, so 3 points down and 4 points to the left in the negative x direction, because this again gives you a triangle where the hypotenuse value is 5, your base is 4, and then your perpendicular length is 3. So the value, the coordinates of A would be, so if your midpoint value, the x coordinate of midpoint is 1, you moved 4 points to the left, so 1 minus 4, and then your y coordinate would be, you moved 3 points down in the negative y direction. So 2 was the midpoint, and then you moved 3 points. So A would be 1 minus 4 is negative 3, and 2 minus 3 is negative 1. So A is negative 3 and negative 1, and B is 5, 5. All right, let's move on to question number 15 here. So it says that the diagram shows the lines x plus y equals to 8 and 2y equals to x plus 4. The shaded region on the diagram is defined by 3 inequalities. Write down these 3 inequalities. So this is the shaded region here. The 3 boundary lines are this one, the first, this is the second one, and the third one is this, which is the y-axis. So basically we have to figure out which of the equation line like belongs to which of the lines here. So you can see here that this one line has a gradient which is positive, the other one has a gradient which is negative. So if we can write these two equations in the form y equals to mx plus c, and see which has a positive gradient and which has the negative gradient, we can assign these equations to these two lines here. So let's do the first one here. So it's x plus y equals to 8. So if I take x to the other side of the equation, I get y equals to minus x plus 8. And then if I take this equation here, I get y equals to x by 2. I divide by 2 on both sides, and I also get plus 2 here. So this, the line that is represented by this equation, the gradient is negative 1, and here the gradient is 1 by 2. So basically, this line is x plus y equals to 8 with the negative gradient, and this line is with the positive gradient. The equation is y equals to x over 2 plus 2. So the shaded region is below this line. So the inequality, first inequality could be written as x plus y is less than equal to 8. The shaded region is above this line. So that means we can write this as 2y is greater than equal to x plus 4. So I'm basically writing the original equations, not the ones that I modified to basically represent in this form. So you can write this as well, but I'm just writing the ones that are given in the question. So the third one is the line here, which is the y-axis. So you know that the equation for y-axis is x equals to 0. So then, since this is the shaded region is towards the right side of the y-axis, the inequality becomes x is greater than equal to 0. So the third inequality that represents the shaded region is x is greater than equal to 0. So part B is another region R is defined by the inequalities x plus y is less than equal to 8, 2y is less than equal to x plus 4, and y is greater than equal to a, where a is an integer. This region contains 5 points with integer coordinates. Write down the value of a. So let's see. So this region again has 3 boundaries. The first one is x plus y is less than equal to 8. So this is the line represented by x plus y equals to 8. So anything below this here, and then it also states 2y is less than equal to x plus 4. So below this line as well as below this line. So this becomes this whole region which is below these two lines. And our third inequality is y is greater than equal to a, which means it's a horizontal line somewhere, and it's represented by its y is greater than equal to a, so the y value here would be a. So we need to find the value of a. Is it this one, something below, or something below, or something above? So basically we need to adjust this line until we get 5 points inside the region which have integer coordinates. So let's start on from the top. So we know that this is the top of the region where these two lines intersect, since the region R is below these two lines, so anything below this. So we have to adjust this, has to come somewhere here or somewhere here, this y equals to a line. So let me just remove this quickly. So we have to adjust this value of a until we have 5 points in the region with integer coordinates. So let's start from the top. Let's assume that the line y equals to a is right about here. So there would be only, so if this is a and y is greater than equal to a, so that means the only point in the region is this one with integer coordinates. This has value, x coordinate is 4 and y coordinate is 4 as well. But we need 5 such points. So if we move to like have more points in the region, we need to move this line y equals to a one step below. So if we place it here, then this is the only way we can add more points, right? If we place it somewhere in between, we do get more points in the region, but they don't have integer coordinates. Those would be like something here would be 3 point something on x and then 3 point something on y. It is not until we move this line here that we get more points in the region. Remember, this inequality is less than equal to, less than equal to, and greater than equal to. That means any points on the line are also part of the region. So if we move the line here, which is y equals to 3, then we get this point as well in the region, which is 2, 3. Oops. 2, 3. Then we also get this point in the region, which is 3, 3. This point as well, which is 4, 3. And this point as well, which is 5, 3. So now we have 1, 2, 3, 4, 5 points in the region if our value of a is 3. And this is what we want. We want 5 points which are inside this region R, which also have integer coordinates. So all these points are on the boundaries, like on the lines. And since lines are part of the region, because it's less than equal to, less than equal to, and greater than equal to, so we have 5 points that have integer coordinates. All the points in this region, they are also in region R, but they don't have integer coordinates. So 1, 2, 3, 4, 5, and that satisfies the condition. So A would be equal to 3 here. All right, let's move on to the next question. Question number 16 is Anil has some sweets with a mass of 600 gram, correct to the nearest 10 grams. Write down the lower bound of the mass of sweets. So your degree of accuracy is 10 grams. So your error is basically half of your degree of accuracy. So error would be equals to 10 divided by 2, which is 5. So to compute the lower bound, we can do is 600 minus 5, which is 595. So your lower bound of the mass is 595 grams. So Anil sells the sweets in small portions. Each portion has a mass of 25 gram, correct to the nearest gram. He sells 10 portions of the sweets. Calculate the lower bound of the mass of sweets remaining. So let's say this portion like represents a box of sweets. So he sells 10 such boxes or portions. Each portion has a mass of 25 gram, correct to the nearest gram. So we have to calculate the lower bound of the mass of sweets remaining. So to find the lower bound, we have to calculate the maximum possible mass of sweets that he sold. So since each box or portion has a mass of 25 gram, we have to compute its upper bound. So error here would be nearest gram, so it would be equal to 1 over 2, which is 0.5. So upper bound for each portion of each portion would be equal to 25 plus 0.5, which is 25.5 gram. Now he sells 10 such portions, so upper bound of 10 portions would be equal to 25.5 into 10, which would be equal to 255 grams. Now you have to calculate the lower bound of the mass of sweets remaining. So your lower bound, let's say lower bound of remaining mass, that would be equal to the lower bound of the mass of sweets, which is 595. Since we were given that the mass is 600, correct to the nearest 10. So the lower bound of the mass of sweets is 595, then minus the upper bound of the mass that was sold, which is 255 gram. So this would be equal to 0, 4, and 5 minus 2 is 3. So 340 grams. So this would be the lower bound of the mass of sweets that are remaining. All right, let's move on to question number 17 here. So in the diagram, the bearing of B from A is 170, bearing of A from C is 060, and bearing of C from B is x degrees. Given that triangle ABC is isosceles, find the three possible values of x. So three possible values of x would be the three combination of sides that could be equal to make this triangle ABC isosceles. So you could have AC and AB equal, or you could have AC or BC could be equal, or you could have AB and BC as equal. So we'll solve for x for these three possible cases. So so first of all, we can compute some angles already, given that these bearing lines are parallel to each other. So let's say if I extend this line here, since this line and this line is parallel, this angle becomes the alternate interior angle for this angle. So the alternate interior angles, as we know, are equal. So this becomes 60 degree. Since this is 170 degrees and this is a straight line, that means this angle here would be 10 degrees, because we know that for a straight line, the total angle is 180. And then since this is 10, we again know these two lines are parallel, and this angle here also becomes 10 degrees because these two are alternate interior angles. So now let's start with the first pair of lines that could be equal. These are AC and say AB here. So that means this angle, let me call this Y. If this is Y and this is an isosceles triangle, so this would be Y as well. So the value of X would be, we can find the value of X if we know Y, because we know that this full angle is 360. So if we subtract 10 plus Y from 360, we get X. So now the first case here is when AC is equals to AB, we get y plus 70, which is the sum of these two, to become the angle A here. And since these three are angles of a triangle, this should sum up to 180 degrees. So this gives you 2y equals to 110, and then y equals to 55 degrees. So if we want to compute the value of x, x would be x plus y plus 10 should equal 360. So x would be equal to 360 minus 10 minus 55. So x would be 295 degrees. So your first possible value of x is 295. So the next possible case, let me bring the eraser here. Remove this, this y, this, and this here as well. The next possible case is we can say that second case would be AC is equals to BC. So these two lines are equal to make this ABC triangle an isosceles triangle. So that means, let me call this Y here again, this angle as Y. Since these two lines are equal, these two angles should be equal as well. So if this is 70 degree, then Y we know is 70 degree as well. So we can compute x again. So 360 minus 10 minus 70. So x in this case would be 360 minus 80. That would be 280 degrees. So second possible value of x is 280. The third case is when, say, which is the remaining one, AB and BC are equal. So AB equals to BC. Me again this. So AB is this one. This is equals to BC here. So that means if this angle is y again, and these two sides are equal, so this whole angle is 70, that makes this angle 70 degrees as well. So the value of y would be y plus 70 plus 70 equals to 180, and this gives you y equals to 180 minus 140, which is 40 degrees. So in this case y is 40, so your value of x would be 360 minus 40 minus 10, and in this case this would be equals to 310 degrees. So your third possible value of x is 310. So let's move on to the next question, which is question number 18. The diagram is the speed time graph for a part of car's journey. The retardation of the car between t equals to 8 and t equals to 12 here is 4 meter per second square. We have to find the value of v. So we know that retardation or the deceleration of a car would be given by the change in speed divided by the time interval. So your acceleration or deceleration is basically the rate of change of speed with respect to the time. So we're given that retardation is 4. The change in speed is from v to 0, so that would be v equals to 0, and your time interval is 4 seconds. It started at 8 and ended at 12, so 12 minus 8. So 4 equals to v by 4 here, and this gives you v equals to 16 meter per second. So v would be 16 meter per second. Part B is find the total distance traveled by the car in the 12 seconds. So the distance, is for speed time graph, the distance is given by the area under the graph. So this is trapezium. So your distance would be equals to the area of this trapezium, which is 1 by 2 into height into side 1 plus side 2, which are the two parallel sides. So 1 by 2 into height is given by v here. So we know that the value of v is 16, and then the length of two sides is one is from this point till this is 12, and the other side is 8. So this would be equals to 8 plus 12. So this cancels out and you get 8 into 20, which is 160 meters. So your answer is 160 meters. Let's move on to question number 19. Yep. So we're given this diagram, and AB is the diameter of the circle with center O. PA and QB are tangents to the circle at A and B respectively. Prove that triangle PAO, so this one on the top, is congruent to triangle QBO, which is this one at the bottom here. Give a reason for each statement you make. So I find that to solve these type of questions, it's better to start, marking all the angles or sides that we know that are equal, so that we can see which property which test basically we can use to prove that these two triangles are congruent to each other. So we know that since this is the A and B, AB is the diameter of the circle, that means that AO and OB are both radius. So this side and this side is equal. So AO equals to OB because both are radii of circle. Then you can also see that this angle here would be equal to this angle here. So your angle POA would be equals to BOQ because they are vertically opposite angles. And then since we know that these two lines are tangents and these lines are radius, so that means this angle here would be 90 degree and this angle here would be 90 degree as well. So angle PAO equals to angle OBQ, which is equals to 90 degree because it's an angle between radius and tangent. So we have two angles here that are equal and two angles here that are equal. Both are 90 degrees. And then we have a side in between those angles, which is also equal. So this basically means that we can prove that these two triangles are congruent by the AAS congruence test, which is basically two angles and their corresponding side in between are equal. Then if that is true, then the two triangles are equal. So AAS, uh, two angles and their corresponding side is equal. So triangle PAO and triangle QBO are congruent. Congruent is RUENT. So yeah, I think that's a nice way of doing these type of questions where you basically start marking angles and sides that you can see are equal, and then once you're done, then it will become clear which congruency test that you can use to prove uh, the two triangles are congruent. So let's move on to question number 20. So a bag contains 10 counters, of which 8 are blue and 2 are white. 2 counters are taken from the bag at random without replacement. So you take one out and then you take the other out, the second one out, without putting the first one back in. So complete the tree diagram to show the possible outcomes and their probabilities. So you have initially you have bag with 10 counters. 8 are blue, so the probability of picking a blue one is 8 over 10, and 2 are white, so the probability of picking a white one is 2 over 10. So then we move on to picking up the second counter. So if you pick the blue one the first time, that means there are 7 blue remaining. So you get the probability of picking the blue as 7 by 9. So you're already at this stage where you picked up the first one and then you're picking the second one. And since there are now 9 remaining, of which 7 are blue, so you get a probability of 7 by 9. If you pick the first one as blue, the second one, the probability of getting the second one as white would be 2 over 9, because there are still 2 whites remaining. Remember, there were a total of 2 whites, and the first one you picked was the blue one. So you have 2 whites, and there are a total of 9 in the bag remaining after the first pick. So you have a probability of 2 by 9 of getting a white one. Now, if you pick the first one as white, then picking the second one as blue, we know that the denominator would again be 9, since there are 9 remaining counters in the bag. So if you pick the first one as white, there are still 8 in the bag that are blue. So probability of picking a blue would be 8 over 9. 8 blue out of the total 9 remaining. And then again here, still 9 remaining. You pick the first one as white. Then how many white are remaining? Which is, since you picked the first one as white, there were only 2 at the start, so you only have 1 remaining white left in the bag. So the probability of picking a white one the second time is 1 over 9. Now the second part is find as a fraction the probability that both counters are blue. So that means we have to go first one blue and then the second one blue. So probability of getting both blue would be, let's say, probability of P1 of B multiplied by P2 of B. So what do I mean by that is uh, probability of getting both counters blue means you get a blue the first time and the second time. So and means you have to multiply the two probabilities. So you get first time you get a blue, probably let me represent this by P1. So P1 of B is getting a blue counter the first time, and then P2 of B is getting the probability of getting the blue counter the second time. So you get blue the first time and the second time. So the first time the probability of getting blue is 8 by 10. So you get 8 by 10 here, and then blue for the second time is 7 by 9. So you get 8 times 7 is 56, and then 90 in the denominator, and then you can simplify it by dividing by 2. 2 2s are 4, 1 16, 28 by 45, and yeah, I think that should be the simplest form for this. So probability is 28 by 45. So you have to, the second part is one counter is blue and the other one is white. So this probability of one blue and the other one is and other white. So that could happen two ways. You pick the blue one the first time and a white one on the second turn. So you get blue white, or you pick the white one the first time and a blue one the second time. So you can get, so this would be equal to probability of getting blue and white, or probability of, oh, sorry, let me erase this. So probability of getting blue and then white, or probability of getting white and blue. So either of these two cases uh, will give you one counter that is blue and one counter that is white. So what is the probability of getting blue and white? So blue and then white. So you multiply 8 by 10. So you get blue in the first turn, and then you get white in the second turn, which is 2 by 9 here. So 2 by 9 plus. So you can get blue or and white, or you can get the white in the first turn and the blue in the second turn. So white in the first turn is, so let me just do this so that, and then white in the first turn is 2 by 10, and then blue in the second turn is 8 by 9. So you have 16 by 90 plus 16 by 90, which is 32 by 90, which is 16 by 45. So this is your answer. So there's a probability of 16 by 45 that you will get one blue and one white. Since it doesn't specify the order, we have to consider both cases in which you could get blue and white, or you can get white and blue. If it specified the order, like if it said the first one is blue and second one is white, then we would only have considered this case where we have the first one is blue and the second one is white. So here in this case, your answer would be 16 over 45. So the next question, question number 21 is, the table shows the values of the function f of x for some values of x. Express the function f of x in terms of x. So you have a function whose values are 5, 7, 9, 11, 13 for x equals to 1, 2, 3, 4, 5. So if you notice this, this is actually a sequence of numbers where the difference between the two consecutive numbers is always uh, 2. So if you add 2 to the previous number, uh, you get the next number in the sequence. So 5 plus 2 is 7, 7 plus 2 is 9. So if you start writing the terms of the sequence here, so you have the first term, let me represent it by 1, is 5. The second term here is 5 plus 2, which is 7. And the third term here is 5 plus 2 plus 2, which is 9. And the fourth term here is 5 plus 2 plus 2 plus 2. So for each term, you're adding a multiple of 2 to 5. So for the fourth term, you're adding 2 plus 2, 4 plus 2, 6. So you're adding 3 times 2 to 5. And for the third term, you're adding 2 times 2 to 5. So the number of times you're adding 2 is basically one less than the number of the term number in the sequence. So for the fourth term, you're adding 3 times 2. For the third term, you're adding 2 times 2. So your sequence is something like this. So 5 plus 2 multiplied by x minus 1, where x is the the term number in the sequence. So for x equals to 1, you'll get 1 minus 1, 0 times 2 is 0, and then you get 5 plus 0 equals to 5. So similarly, you can find out the fourth value here if you replace x with 4. 4 minus 1 is 3, 3 times 2 is 6, 6 plus 5 is 11. So basically, your function f of x would be equal to 5 plus 2 times x minus 1. Your function f of x represents this number sequence, where instead of usually we use n as the notation for the nth term. Here you have x as the notation for the xth term. So you can find the xth term of the sequence using this formula 5 plus 2 times x minus 1. You can simplify it by multiplying the 2 inside 2x minus 2, and 5 minus 2 is 3, so you get 2x plus 3. So f of x is 2x plus 3. So it was, although it was a question for functions, but it was a classic example of the sequence of numbers where you start with one number and then you keep adding 2 to it. So your first term is 5, second term is 5 plus 2, then third term is 5 plus 2 plus 2. So from this, once you expand this, you see that you're basically adding a multiple of 2 to 5 each time. So for example here, for the fourth term, you're adding uh, n minus 1. 4 minus 1 is 3. 3 times 2, which is 6. 2, you add that to 5 to get the fourth term. So uh, again, as it was stated here, that it's a function problem, but it was represented, the function was represented as a sequence. So you solve it using the sequence methods that you have learned. So the next part is evaluate g of minus 2, where g of x is this. So you simply substitute uh, the value of x here with minus 2, so that would give you 8 minus 3 times negative 2 over 2, which is 8. 3 times 2 would be 6, and this becomes positive. 8 plus 6 is 14 by 2, which is 7. So your answer is 7 here. Then you have to find the inverse of x. So to find the inverse of x, we say that let y equals to g of x. So then this also gives you x equals to g inverse of y, because if you want to make x the subject, you take inverse on both sides. You get x on this side and then g inverse of y on the other side. So since y equals to g of x, you can write y equals to 8 minus 3x by 2. And similar to how you have learned to make x of the subject of the equation, you take 2 to the other side, you get 8 minus 3x equals to 2y, minus 3x equals to 2y minus 8, and then x equals to, take the negative 3 to the other side, you'll get 8 by 3 positive 8 by 3, since this is negative 3, and then you get negative 2 by 3y, or you can write it as 8 minus 2y by 3. Since we know x is g inverse of y, we can substitute g inverse of y equals to 8 minus 2y by 3. And then if g inverse of y is this, you simply write it as g inverse of x would be, you substitute y by x, you get 8 minus 2x over 3. So your g inverse of x would be 8 minus 2x over 3. Let's move on to the next question. So question number 22 is the table shows the populations correct to two significant figures of some African countries in 2014. So you have countries and their population. In 2014, the population of Nigeria was this. Complete the table with the population of Nigeria using standard form correct to two significant figures. So to represent this in standard form, we need to uh, have the decimal right here. So to move the decimal to this point, from this point, you're moving 1, 2, 3, 4, 5, 6, 7, 8 places. So that would give you 1.77156000 into 10 to the power 8. Since we have to represent this in two significant figures, so one is your first significant figure, and then you have to, so you'll have to go up till the first decimal place. So since the second decimal place is 5 or greater than 5, 7 in this case, so you'll round it up to 1.8 into 10 to the power 8. So you can fill it up here into 10 power 8. So the next part is complete the following. The population of Chad was dash times the population of Namibia. So to compute that, you'll have population of Chad divided by population population of Namibia. So Chad is 1.1 into 10 to the power 7 divided by Namibia is 2.2 into 10 power 6. So this we can cancel out easily. 1.1 over 2.2 is 1 over 2. If you cannot see this right away, you can remove this decimal. This becomes 11. You can remove this decimal as well. This becomes 22. 11 by 22 would be 1 by 2. And then you bring this up, so you'll get 7 minus 6. So you'll get into 10 to the power 1, which we can write. We don't need to write the number 1 here. And then 10 by 2 would be equal to 5. So the population of Chad was 5 times the population of Namibia. Part C is the population density of a country is measured as the number of people per square kilometer. It can be found by dividing the population of the country by its area in kilometer square. So here, the area of Sudan is given as this. Estimate the population density of Sudan. Give your answer correct to one significant figure. So population density, the question already tells you how to find it by dividing the population of the country by its area. So for Sudan, we have this population 3.6 into 10 power 7 divided by the area, which is this 1.86 into 10 to the power 6. So since we have to give the answer in one significant figure, we can round this up to 3.6 up to 4, and then 1.86 up to 2, and then 10 power 7 divided by 10 power 6 is just 10 power 1, and then this gives you 2 ones are 2, 2 twos are 4, and then 10 times 2 is 20. So this gives you 20 people per kilometer square. So let's move on to question number 23 here. So the table and histogram show some information about the times taken by a group of students to travel to school one day. So 28 students took a time somewhere between 0 and 10 minutes. 40 students took a time between 10 and 20 minutes, and so on. And this is the histogram that represents this table with frequency density on y-axis and then time here on the x-axis. So the first part is complete the histogram. So the two bars that are missing are for the interval 0 to 10, and then the second one that's missing is from 30 to 60. So for 0 to 10, the frequency is 28. So since the interval is 10, you divide 28 by 10, you get 2.8. So each small box here represents 0.2. So the line for 2.8 would be one small box below 3, which is this one here. So this would be the frequency density 2.8 here. Let me just write it properly. And then the second bar that we have to add is for the interval 30 to 60. So since 18 is the frequency here, we have to divide 18 by, so the interval length here is 30, 60 minus 30 is 30. So 18 is less than 30, you add a decimal here, and then 30 times 6 is 180 and 0. So that would be 0.6. So 1 is this line, then 0.8, and then 0.6 would be two small boxes below 1. See if I can get straight here. And then down here. Perfect. So now we have completed the histogram. The part B is find the value of M. So for M, we know that frequency density here is just one block high. So this would be 0.2 here. So value of M, which is the frequency, is basically frequency density multiplied by the interval to get the area under this histogram in this interval. So frequency density is 0.2, and then the interval is from 60 to 120, which is basically 60 here. And then 60 multiplied by 0.2 would be 600 into 2, 1200, 1.2, I guess. Let me quickly multiply here. So you get 120, and then you place the decimal here. So it should be 12. So the answer is 12. The value of M is 12 here. Part C is work out the fraction of students who took more than half an hour to travel to school. So the fraction, this fraction would be number of students who took more than half hour and then divided by the total number of students. So let me write it here. Fraction would be equal to number of students who took more than half hour divided by total students. So the number of students who took more than half hour. So that means up till this point, we have 30 minutes. So more than 30 minutes would be 18 plus M. So that would be 18 plus 12. So these are the number of students that took more than half hour to get to school. And then the total number of students is 28 plus 40 plus 52 plus 18 plus 12. So this gives you 30 in the numerator. 18 plus 12 would be 30. And if you add all these numbers together, you'll get 150. So your answer would be zeros cancel out, 3 ones are 3, and 3 fives are 15. So the fraction is 1 over 5 in the simplest form. Let's move on to question number 24. So it says that the diagram shows a sector of a circle with radius 3r and an angle a degree and a circle with radius r centimeter. The ratio of the area of the sector to the area of the circle with radius r centimeter is 8:1. Find the value of a. So the area of the sector, the ratio of the area of the sector to the area of the circle is 8:1. So it will be area of sector divided by area of circle would be equals to 8 over 1. So this, to find the area of sector, we know the formula, angle over 360. So the sector angle of the sector is 8 degrees into pi r square. Pi times your radius is 3r. So 3r whole squared divided by area of circle is pi r square. So this is equals to 8. So this pi and pi cancel out. So you get a by 360 into 9r squared over r squared equals to 8. And then you cancel this r squared with this r square, and you get, I'll continue here at the top, a over 360 into 9 equals to, this is 9, 8. 9 times 1, 9 times 4, and then 40. So a would be equals to 8 into 40, which is equals to 320 degrees. So the value of a is 320. Part B is find an expression in terms of pi and r for the perimeter of the sector. So we have to find the perimeter of this sector. So the perimeter of this sector would be this arc length plus this radius and this radius. So let me write it here. Perimeter would be equals to arc length plus 2 times 3r. Since radius is 3r, we'll add it 2 times, so 2 times 3r. So arc length would be equals to a by 360 into 2 pi into r, which is again radius is 3r, plus 6r. So since a we know is 320, we can write it as 320 divided by 360. So if we multiply here, we get 3 times 2, 6 pi r plus 6r. And then you can simplify this, zeros cancel out. 4 times 8 and 4 times 9 is 36. So you get, you multiply 8 by 6, you get 48 pi r over 9 plus, this is 9 plus 6r. So this would be your final answer. I can write it down here as 48 pi r over 9 plus 6r. In fact, I just realized I can simplify this even further. So this won't be 48 over 9. I can write this in its simplest form. So these both are divisible by 3. So this would be 3 times 3. 3 times 1, then 18, so 16. So this could be written as 16 pi r over 3 plus 6r. Let's move on to question 25. So the nth term of a sequence is given by this n squared minus 5n. Find the second term in the sequence. So second term in the sequence t2, let's say, is equals to 2 squared minus 5 times 2. What you did is you basically replaced n with 2 since we are looking for the second term. So this would be equals to 4 minus 10, which is -6. So your answer is -6 here. Second part is the pth term in the sequence is 150. Find the value of p. So let's say the pth term is represented by tp, and it's given as, if we replace p in the sequence formula that we are given, we'll get p squared minus 5p, and we know that this is equals to 150, so you get p squared minus 5p equals to 150, and then p squared minus 5p minus 150 equals to 0. And then this is a quadratic equation that we can factorize. So if I multiply this -150 with the number with p, which is 1 here, so -150 times 1 is -150. So I'm looking for the factors of -150. Since it's negative, I need to find two factors whose difference is equals to 5. So you can quickly say that 15 are 10. 15 and 10 are the two numbers that we're looking for. 15 minus 10 or 10 minus 15 is -5, and minus 10 times positive 15 is -150. So we can write this as p squared plus 10p minus 15p minus 150 equals to 0. Then we factorize p common here, p plus 10 minus 15 common here, you get p plus 10 goes to 0. Let me continue here at the bottom. So you get p plus 10 times p minus 15 equals to 0. So p equals to -10 or p equals to 15. Now you have two values. Since p is the pth term in the sequence, it cannot be a negative value, right? You cannot have -2 value. Sorry, you cannot say that find me the negative third value of the sequence. You always start the sequence values with the first value in the sequence, the second, the third, and so on. So this will be not correct. So this is not applicable here. So your value is 15. So the 15th value in this sequence is 150. And to double check, you can actually substitute 15 in this here in this equation. So just to double check, 15 squared negative 5 times 15, and 15 squared is 225, and then minus 75, which is 150 as given here. So we ignored the -10 because you cannot have a negative third or negative fourth value in the sequence. The value of this, the value could itself be negative. For example, here the second value is -6, but you cannot go like negative third value in the sequence. So you can ignore the negative value here. The other value is 15. So your answer P is equals to 15. So part B is the nth term of another sequence is given by 3n squared negative kn. The fifth term in this sequence is 55. Find the value of k. So T5 would be given by, if you replace n by 5, so you get 3 into 5 squared minus 5k. And you're given that the fifth value is 55 here. So 55 would be equals to 5 squared is 25. 25 times 3 is 75 minus 5k. You take 55 to the other side, 75 to the other side, 55 minus 75, negative 5k. And if you subtract, you get negative 20 equals to negative 5k. Negative, negative cancel out. You take 5, divide 5 by both sides. Oh, sorry, divide both sides by 5 and you get 4. So the value of k is 4 here. So I think this is the last question. Yeah. So the last question, 26, question number 26 is make P the subject of the formula. So you have T equals to P plus 3 divided by P minus 4. So if you multiply, if you take this to the other side, you get T times P minus 4 equals to P plus 3. So you get Tp minus 4t equals to p plus 3. Now what you have to do is have the terms which have p on one side of the equation and all the other terms on the other side. So I can bring this p here. This would be Tp minus p, and then I can take this negative 40 to the other side. So that will give me 3 plus 40. And then if I take p common, I'll get t negative 1 equals to 3 plus 4t. And then p would be equals to 3 plus 4t divided by t minus 1. So you'll get here is 3 plus 4t divided by t minus 1. The last part, part B, is uh, simplify fully this equation, 4x squared negative 1 divided by 2x squared minus 9x minus 5. So here on the top, you can use the formula a squared minus b squared equals to a plus b times a minus b, and we can factorize the denominator as well. So you'll get 2x plus 1 times 2x minus 1. Since this is basically, let me in fact show you all the steps so that it's clear. So we can write 4x squared as 2x whole square, and this is 1 whole square. The square of 1 is 1, so we can write this as this. And then in the denominator, so this is negative 5 times 2 is negative 10. So you have to find the factors of negative 10 that we subtract to get negative 9. So this is -1, oh sorry, negative 10 times positive 1. So if you multiply these two, I get negative 10. But if I add these two, negative 10 plus 1 is negative 9 that we have here in the middle. So this would be 2x squared negative 10x plus x minus 5. So then in the numerator, I can write this as 2x using this formula. A square minus b square that I have here is a plus b times a minus b. So I get 2x plus 1 times 2x minus 1. And then here I can take 2 common x. In fact, I can take 2x common here. I'll get x minus 5. And then nothing is common here. I can write plus 1 times x minus 5. This gives me 2x plus 1 times 2x minus 1 divided by 2x plus 1 times x minus 5. And these cancel out, and then I get 2x minus 1 over x minus 5. So the final answer would be 2x minus 1 over x minus 5. So that's it. That's the May-June 2016 paper 1 variant 2.